Okay, the title of this video is The Number Line. We feel we're all familiar with numbers. They have a definite order to them, and so some are larger than others, and we can represent that by ordering them along a number line.
Okay.
So this is our number line, and it's getting bigger going from left to right, and the numbers get smaller as you go from right to left.
Okay.
0 is our reference point.
Okay.
We like reference points in maths, they're a useful thing to have. The digits are labelled out either direction from 0. 1, 2, 3. But this side they're positive, this side they're negative.
Okay.
That can occasionally cause confusion when you're talking about comparing the size of numbers. Remember that everything this side on the right is larger than anything on the left. Okay. So let's look at 3 and 1. 3 is obviously larger than 1 because it's to the right.
Yep.
When you do the same digits but as negative values, -3 and -1, -1 is to the right of -3. So -1 is larger than -3.
Okay.
So all you've got to remember is that they go left to right, getting larger, and that your digits spread out from 0.
Okay.
We've got our single digits going out either way, evenly spaced along the number line, but there are gaps between them. So what do we do about those gaps? Let's think about what might happen at, say, this point here. Can we label this point with a digit?
Okay.
Can you?
Well, that looks halfway between 1 and 0, so I could call that a half.
You could call it a half.
1 over 2.
Yes. Okay. However, that is not unique.
Okay.
Is there something else that you could call it?
In decimal form, I could call it 0.5.
Okay, let's put that up here. So those are two labels for exactly the same point on the number line. And as I say, they are not unique. You can have a whole range of numbers. So we've looked at fractions and equivalent fractions.
Yep.
So can you think of an equivalent fraction to a half?
Well, another one would be 2 over 4.
Okay, I'm going to put that just up here.
2 quarters.
So again, all of these are equivalent, labelling the same point. And you might like to think of it as that we would like to be able to convert between different representations of the same number. You might like to think of it as translations. In languages, you can have the same word for the same, different words for the same item. So in French, German and English, you might have words for the chair, they might all be different, but you have a means of translating between them so you all know what a chair is.
Okay.
Similarly, we will have ways of converting between different numbers, and we'll look at that in other videos. Again, we can have other points on the number line.
So again, it's halfway between 1 and 2, so 1.5.
Could be 1.5. Can you represent that in any other way?
Yeah, I can do the same thing again as before, and it's 1.5.
Can you represent that as a single fraction?
And yeah, 3 over 2.
3 over 2. And we have the same sort of situation everywhere, and not just halfway between. If we go a quarter of the way along there, this is a quarter of the way along between 2 and 3. What might that be?
So it's 2 plus a quarter, so 2 and a quarter.
2 and a quarter. And similarly, going back this way, what might we have at this point here?
Okay, minus 1.5.
Yes, you can remember it's going.
Yes, it's going that way.
And so on. So long as you can remember that the number line goes left to right, getting larger, the digits spread out from 0, and not every point, well, all the points have multiple representations, and we do have ways of translating between them.